So we have been dealing with the numerical problems. So we have already discussed the numerical problem based on law of flotation. Now the next topic that I'm going to do is I'm going to teach you to find the volume of displaced water. Okay, volume of displaced water. Now whenever an object is kept in a liquid, so we have to find the volume of displaced water. On an exam we may simply ask the amount of displaced water. Now when it says the amount, you should, whenever you talk about amount of displaced water, we should find at least two things. One, you can find the volume, and next one you can find the mass. Okay, so we'll find the it's better to find both. Okay, now in this series we'll talk about the amount of displaced water. So the object can be denser than water, or it can be lighter than water. So we have two cases here to do. So let's start. So when you solve for amount of displaced water, we'll generally face two cases. In the first case, so we have to see the density. So when the density of object is greater than density of water, so this will be the first case. Now we know that whenever the density of object is greater than density of water, this means this is the case of sinking. Okay, when an object sinks, so this we have one scenario over here. So the next condition or the case might be, okay, so you can think the next case is that density of water is greater than density of object. Now in this case the object will float, and we have to find the volume of displaced water. Now if the density of water is greater than density of object, we can simply apply what law of flotation, and by applying the law of flotation we can find this. So you can see the videos on the law of flotation, okay, on the laws of flotation that we made before. So from there you can get the concept. Okay, so now for right now let's deal what happens when object sinks. Okay, in this case how do we find the volume? Now in this case, you must we have already done this case. Okay, we have done, I mean to say that when we okay, so we know how you find the volume of stone, that means irregular object. Now we know the volume of stone or irregular object, this will be equal to, this will be equal to volume of displaced, volume of water displaced or displaced water. Okay, volume of displaced water. So we have the concept that volume of displaced water, which will be asked to find. So volume of displaced water will be equal to volume of stone. That means first thing we have to find the volume of stone. Now how do you find the volume of stone? So to find the volume of stone, you must be given two things, because we have a formula, density is equals to mass by volume. So to find the volume of stone, you must have the information what is the density of stone and what is the mass of stone. So this two things will be given, and once these two things are given, we can find the volume of stone, and once we have the volume of stone, we can easily find the volume of displaced water. So let's do a numerical. So this is the problem. A brick of mass 1 kg and density, so mass is given 1 kg and density 2.5 gram per cm cube is immersed in water. How much mass of water is displaced by it? Now see, first thing we have to focus density of brick. So density of brick is 2.5 gram per cm cube, and we must know that though the density of water is not given over here, but we must have this in concept in our mind, that density of density of water. Okay, now density of water, that is equal to 1 gram per cm cube. Now we can clearly see that the density of brick is greater than density of water. This means the brick will, so this means the brick will sink. Okay, and the brick will sink. This is the first condition we talked before, that is whenever the condition of sinking. Now in this condition, what is the idea, what is the central idea? Okay, and we know that in this condition, volume of, okay, now see, to find the mass of displaced water, first we have to find the volume. So the volume of water displaced, okay, volume of water displaced, so this will be equal to volume of brick. Okay, now that means we have to first find the volume of brick. Okay, so how can you find the volume of brick? If we go over there, now we know the formula. Okay, I'm not doing everything formally, I'm just trying to give you the central idea. So we have the formula: density of brick will be equal to mass of brick divided by volume of brick, or now density of brick is given 2.5. Okay, 2.5 gram per cm cube, and the mass of brick is given in kg. I'm going to convert into, okay, CGS system, so that will be simply 1000 gram, and the volume of brick we don't know, that's the volume of brick, so that is VB. Now if we solve this, so we'll get, this is VB is equals to 1000 divided by 2.5. if we cancel out, so if they cancel out, so we'll get, this will be 400. So the volume of brick is 400. Now what is the unit? Okay, we have used all the CGS units, so volume must be also in CGS, so that is centimeter cube. Now we know that from Archimedes idea, okay, from Archimedes, ARCHI, from the Archimedes, okay, from the Archimedes concept. So the volume of displaced water must be equal to volume of block, and that is equal to 400 cm cube. Now we have to find the mass of displaced water. So we have density of water, this will be equal to mass of water divided by volume of water, or I can write mass of water equals to density of water into volume of water. So density of water in terms of CGS unit, because we are all using CGS unit, that is 1 into the volume of water, displaced water is 400, so we have 400 gram. And if you wish to convert into kg, we can do that. So this is 400 divided by 1000, so this will come into kg. These two are cancel out, so that will be 0.4 kg.